Data collection plan. Let's begin by understanding why a data collection plan, or DCP, is vital in any Lean Six Sigma project. First and foremost, a DCP ensures that everyone involved interprets the data collection process in the same way. This alignment avoids confusion and sets the foundation for consistency. Next, it brings clarity and consistency to how data is collected, measured, and understood. Critical elements when we're trying to draw reliable conclusions. It also eliminates ambiguity. This is important because ambiguity in data leads to poor decisions. With a strong DCP, we're ensuring decisions are based on reliable and accurate data. Now, a well-prepared DCP does more than just align data. It aligns the entire project team, data collectors, and stakeholders. It ensures everyone knows what data needs to be collected, when it should be collected, and who is responsible for it. Even outside of formal Lean Six Sigma projects, these principles are powerful. You'll find DCPs extremely useful in areas like organizational dashboards or routine performance reporting, where consistent and structured data collection is key to meaningful insights. One of the most critical goals of a data collection plan, or DCP, is to eliminate ambiguity in how data is collected and interpreted. Ambiguity in data collection can lead to inconsistent or unreliable results, especially when different team members interpret data in their own way. That's why the DCP enforces standardization. There are two key expectations for every person involved in the data collection process. 1. They must clearly understand the critical to quality CTQ metric. This ensures everyone is measuring and evaluating data based on what truly matters to the customer. 2. They need to follow a standardized approach when collecting and recording data. Standardization promotes consistency and minimizes subjectivity. Without these two anchors, CTQ clarity and standardization, teams are likely to face misaligned interpretations, which compromises the entire integrity of the project's insights and decisions. Now let's talk about one of the most critical components of a data collection plan, the operational definition. An operational definition is a precise, agreed-upon description of how a specific critical to quality CTQ metric will be measured. It removes any guesswork or assumptions about what exactly is being measured and how. Why is this important? 1. It ensures that everyone measures the same characteristic in the same way, regardless of who is doing the measurement. 2. It makes the results repeatable and reproducible. This means if different people collect the same data using the same method, the outcomes will be consistent. 3. Most importantly, it makes sure the measurement method is relevant to both the organization and the customer, aligning internal processes with external expectations. Without operational definitions, data can quickly become inconsistent and unusable, defeating the entire purpose of your data collection effort. Let's take a closer look at what an operational definition really provides in practical terms. In short, an operational definition does 4 key things. It removes ambiguity by clearly stating how a measurement should be performed. It defines exactly what to measure, so there's no confusion about the characteristic or parameter being assessed. It specifies how that characteristic should be measured, ensuring consistency in tools, techniques, and timing. And it clarifies when a result is acceptable or defective, helping us judge performance based on defined standards. This leads to 3 major benefits. 1. Everyone involved in the data collection process will measure the characteristic in exactly the same way. 2. The data becomes repeatable and reproducible, regardless of who is collecting it. Whether it's a team in India or a team in the US, the result remains consistent. 3. Most importantly, the method of measurement becomes meaningful to both the organization and the customer, reinforcing confidence in the process and the outcome. Remember, without a solid operational definition, Your data is vulnerable to interpretation, and that's something we can't afford in Six Sigma projects. When setting up a data collection plan, one of the key elements we need to define is the performance standard. A performance standard specifies what is acceptable and expected by the customer for a particular critical to quality (CTQ) characteristic. It answers three essential questions. 1. What does the customer expect? This ensures the project is aligned with actual customer needs, not just internal assumptions. 2. What defines a good product or process? This helps differentiate acceptable outcomes from unacceptable ones. 3. What qualifies as a defect? Defining this clearly is critical for accurate defect tracking and process improvement. By setting these performance standards, we provide the project team with clear direction. These standards guide the team toward meeting customer expectations and ensure that all activities align with the project's goal statement. Ultimately, performance standards create a shared understanding of success across the team and serve as the benchmark against which outcomes are measured. Once performance standards are defined, the next important concept to understand is specification limits. Specification limits act as boundaries between customer satisfaction and disappointment. If the process output stays within the limits, the customer is likely to be satisfied. If it falls outside, dissatisfaction, what we call a defect, is the likely outcome. We typically describe this as inside the limits, customer satisfaction; outside the limits, customer disappointment. Even when customers don't explicitly tell us what the limits are, they're implied by what they accept or reject. Think of it like this. If the customer repeatedly sends something back or complains about a particular issue, they've just shown you where a boundary lies. These specification limits are not just numbers. They represent what the customer views as acceptable performance, and that's why understanding and respecting them is key to delivering quality. In this section, we focus on a crucial element of the data collection plan: defining defects. The defect definition links directly to the project's Y metric, which represents the output we're trying to improve. It gives us a clear and measurable way to determine what counts as a defect. Let's look at this example to understand it better. The project Y metric is accuracy score per agent per day. The performance standard is greater than or equal to 95% accuracy. So the defect definition becomes, if any agent scores below 95% accuracy on any day, it is classified as a defect. This clarity is powerful. It removes guesswork and ensures everyone involved in data analysis is working from the same definition. Whether it's the operations manager, quality analyst, or team lead, they'll all classify and report defects the same way. Clearly defined defects ensure we can consistently track performance and focus our improvement efforts where they are truly needed. Beyond operational definitions and defect definitions, a well-rounded data collection plan, DCP, should include several other key components to ensure clarity, consistency, and quality of the data collected. Let's walk through each of these elements. Data type. Identify whether the data is continuous, like time or weight, or discrete, like count of errors. This determines the kind of analysis we can perform. Formula used. If applicable, document the calculation method, for example, how averages or rates are computed. This avoids discrepancies across data collectors. Data items. Specify the exact variables to be recorded, like response time, number of calls, or defect type. This ensures we're all capturing the right information. Unit of measurement. Clarify the units such as seconds, meters, or percentages. This prevents misinterpretation, especially in global teams. Decimal precision. Define the number of decimal places to be recorded. This maintains consistency and avoids rounding errors in analysis. Measurement equipment. Lastly, list the tools or instruments to be used. This could be a stopwatch, survey software, or a particular sensor model. Consistent tools ensure consistent results. By documenting these details, your DCP becomes a powerful tool for ensuring that the data you collect is reliable, valid, and usable for process improvement. In addition to the core components we discussed earlier, a truly comprehensive data collection plan, DCP, must also address several administrative and operational aspects to ensure smooth execution and accountability. Let's look at the additional elements listed here. Equipment calibration. Info. This tells us the calibration status or schedule of any measurement tools used. Calibration ensures data accuracy and reliability. Data storage location. Clearly define where the data will be stored. This could be a database, a spreadsheet, or a log sheet. This is essential for easy retrieval and data security. Database creation. Date. Document the date the data container was established to track changes or updates over time. Responsible person. Identify who is in charge of data oversight. This accountability prevents confusion about ownership and follow-up. Training required. Specify any training needed for data collectors. Properly trained personnel are crucial for consistency and accuracy. Operator information. List out who will actually be collecting and recording the data. This makes the plan actionable and ensures responsibility at the ground level. And here's a quick pro tip. Some organizations actually embed their data collection templates right into the DCP. This way, the team has all the tools and guidance in one place for easy access and implementation. This slide presents a sample data collection plan, DCP table, a practical format used to organize and capture all relevant details about the data collection process for a given Y metric. Let's walk through the example shown here, which is based on the monthly NPS %. Net Promoter Score. 1. Operational definition. It defines how NPS is calculated, specifically as the percentage difference between the number of promoters and detractors from the total responses received in a month. Second defect definition. If in any month the NPS drops below 70%, it's classified as a defect. Third performance standard. The acceptable threshold for performance is 70%. Fourth specification limit. The lower specification limit, LSL, is 70%, while the upper specification limit, USL, is not applicable. Now, moving to the mode of collecting data section. The data type is discrete, expressed in percentages. Unit of measurement is not applicable since we're dealing with percentages. Decimal precision is 0, meaning whole number percentages will be recorded. The data will be stored in software using an existing database, and data collection is already ongoing. Lastly, the final row outlines data items to be recorded, count of promoters, detractors, and total responses. The formula used is standard. NPS % equals, open parenthesis, P minus D, close parenthesis, divided by total responses. Equipment, calibration, responsibility, training, and operator information are marked as not applicable in this case because the data is being captured digitally without physical measurement tools. This table serves as a reference model and helps ensure consistency, transparency, and accountability in how data is collected and interpreted across the project team. Now that the data collection plan, DCP, has been finalized, it's time to move into the execution phase. This is where planning turns into action. There are 3 key steps to ensure successful execution. 1. Begin data collection exactly as outlined in the plan. This is crucial. Even small deviations can introduce inconsistencies that affect data reliability and future analysis. 2. Ensure that data collectors follow the plan with no shortcuts. Any improvisation or workaround can distort the accuracy of the data and undermine the integrity of the entire project. 3. Closely monitor the initial phase of data collection. This is the best time to detect and correct any errors, misinterpretations, or inconsistencies before they propagate and skew results. Remember, the success of your analysis depends on the quality and consistency of the data you collect. So, this stage requires vigilance, discipline, and ongoing communication with those responsible for data collection. As we move deeper into the execution phase, it's absolutely essential to focus on data validation before we jump into analysis. Why? Because flawed data leads to flawed decisions. No matter how sophisticated your tools or models are, if the data going in is inaccurate, the insights coming out will be misleading. So before moving forward, we need to validate the data for 3 key attributes: accuracy, completeness, consistency. Ask yourself the following questions. 1. Is the data representative? Does it fairly reflect the population or process being studied, or is there bias? 2. Were the operational definitions followed? Were data collectors measuring and recording exactly as defined in the plan? 3. Are there gaps or inconsistencies? Look for missing entries, illogical values, or unexpected variations that might indicate errors. This step isn't optional. Data validation is non-negotiable. A strong validation process gives you the confidence that the analysis you're about to perform is rooted in trustworthy and meaningful data. Data collection is only as effective as the people performing it. That's why training and communication are absolutely critical parts of any data collection plan. Depending on how complex the data collection process is, here are some best practices you should implement. 1. Provide training for data collectors. Make sure every individual responsible for collecting data understands what to do, how to do it, and why it matters. 2. Use clear job aids, instructions, and examples. Visual or written aids help eliminate confusion and ensure consistency across all team members. 3. Conduct walkthroughs or pilot sessions. These dry runs help ensure everyone understands the process and can perform it accurately before live data collection begins. There's a great quote here that sums this up. The more people understand why and how to collect data, the more reliable your data will be. And that's exactly what we're aiming for. Reliable, consistent, and actionable data that can be trusted during analysis. As we wrap up the session on data collection plans, let's quickly revisit the key takeaways. 1. A well-designed data collection plan, DCP, is essential for project success. It brings structure, consistency, and reliability to your improvement efforts. 2. The operational definition forms the foundation for consistent measurement. Without it, team members might interpret the same metric differently, leading to confusion and error. 3. Involve all stakeholders early. This helps create alignment, reduces misunderstandings, and builds ownership in the data collection process. 4. And finally, always validate your data before analysis. Skipping this step can lead to flawed conclusions, poor decisions, and wasted effort. Remember, good data leads to good decisions. A strong DCP ensures your data is credible, actionable, and aligned with project goals.